All right, let's dive right into this explainer. Today, we're taking a close look at SQLAlchemy. It's this incredible library that basically takes the raw, heavy lifting power of SQL databases and mashes it up with the pure flexibility of Python. Seriously, if you've ever found yourself totally bogged down writing these clunky, repetitive database queries or just struggling to keep your code clean as your data scales, well, you're in exactly the right place. We're going to visually unpack how this tool can completely transform your workflow. It literally turns database interactions from a tedious chore into something that feels, honestly, a little bit like magic. But, before we get super deep into the weeds with database schemas, relationships, and Python classes, the source material actually poses this really funny hypothetical question. What would your job be if you were born in the Middle Ages? I know, it sounds crazy. It sounds like alchemy might be some arcane, obscure library mixing SQL with questionable medieval practices, right? But I promise you, it's actually an incredibly modern, elegant solution.
So, to answer that weird question, the research brings up a pretty fun comparison. Like, if you lived back then, say you were a Dutch citizen, you'd probably be a trader, right? Spending your entire life sailing across these super dangerous oceans, just mapping the globe to find exotic spices like nutmeg. Or maybe you'd be a doctor, which back then basically meant taking the phrase organ player a little too literally. Yikes. Thankfully, today, our jobs are way less messy and way less dangerous. We aren't out mapping the globe on a wooden ship, and we are definitely not harvesting organs. We're just mapping databases, safe and sound, right from the comfort of our keyboards.
To get us comfortable with that mapping process, this explainer is going to follow a very clear roadmap. First, we'll meet SQLAlchemy. 2, the functional approach. 3, the object-oriented upgrade. 4, mastering database relationships. 5, authorization with OSO. And finally, number 6, best practices in action.
Section 1. Meet SQLAlchemy. The basics.
So SQLAlchemy acts as what we call an ORM, which stands for Object Relational Mapper. The absolute core concept to wrap your head around here is mapping. Instead of treating your database like this totally separate alien thing that only speaks in rigid, raw SQL strings, an ORM translates those database rows and tables directly into standard, familiar Python objects. Whether you're just using a lightweight SQLite database for some local testing on your laptop, or you're deploying to massive, heavy-duty production databases like MySQL or PostgreSQL, SQLAlchemy smoothly abstracts all that raw SQL away. It's kind of like having the ultimate real-time universal translator between your application's logic and your data storage. It totally bridges the gap, so you aren't constantly context switching between Python and SQL.
Moving right along to Section 2, the functional approach. Back to basics.
So, moving into our first technical level, this functional approach requires some strict, sequential steps. And honestly, it's highly valuable to understand what happens under the hood here. First, you initialize your database engine. This is basically your core starting point, the central source of truth for everything you do with the database. Next, you create a connection to actually open up a line of communication with it. Third, you manually define your metadata and schema. So here, you are literally telling Python, hey, I have a user table, it's got an integer ID as a primary key, a string username, and an email address. And then finally, you construct and execute your specific queries, like an insert or a select function to actually move data around. It absolutely gets the job done. But as you can probably see, it's super manual, very explicit, and asks you to juggle a lot of structural boilerplate yourself. Now, this step-by-step process actually brings up a brilliant debugging trick from the source. If you're using this functional approach, or frankly, any approach in SQLAlchemy, you can just pass the argument echo equals true right when you're creating your database engine. Doing this tells the library to print out all the raw SQL it's generating behind the scenes, straight into your system console. It's an incredibly helpful way to verify if your Python commands are actually querying the database the exact optimized way you intended. Seriously, it is an absolute lifesaver when you're trying to track down performance bottlenecks.
All right, Section 3. The object-oriented upgrade. Unlocking flexibility. The functional approach we just looked at, perfectly fine for simple scripts. But SQLC's true power really shines with its object-oriented capabilities. This is where your code gets seriously clean and scalable. Let's contrast the two for a second. The functional method is heavily SQL-centric, right? You're writing explicit queries and manually structuring schemas step by step. The object-oriented approach, on the other hand, is beautifully Python-centric. It introduces two major concepts, a session maker and a base class. This setup allows us to treat our database tables as flexible, inheritable Python classes. It completely flips the script. You stop writing static database commands and just start interacting with standard, familiar Python objects. You literally stop thinking about rows and columns and start thinking entirely about instances and attributes.
The workflow here is just incredibly elegant. I mean, it'll save you hours of dev time. Basically, you create a class, let's call it user, and you just inherit from that base object we just talked about. Then you use data class-like mechanisms to map your columns directly inside the class. You just tell Python, okay, an ID is a mapped integer and a username is a map string. You can use the mapped column feature to easily specify stuff like primary keys, unique indexes, or default values. By abstracting away all that dense SQL schema definition, you literally just create a user instance in Python and then use a session to add and commit that user straight to the database. It is entirely seamless. It keeps your app's code hyper-focused on logic rather than the messy mechanics of storage.
Next up, Section 4, Mastering Database Relationships, Connecting the Dots.
Of course, as our app grows, one isolated database table just isn't going to cut it. We have to reach the next level, managing how different tables interact with each other. The cool thing is, you can define these complex relational architectures natively, right inside your Python classes. For instance, maybe you have a one-to-one relationship, linking a user table to a separate user auth table that securely holds their passwords. Or maybe it's a one-to-many relationship, linking one single user to multiple blog posts. You manage this structurally using foreign keys, just like in standard SQL. But here is the real magic. You sync them bidirectionally in Python using a command called back_populates. Think of back_populates like a two-way street. It makes sure that if you update the user's data from a post or access a post from a user, the whole app stays perfectly in sync in memory. No more manually juggling references.
And this object-oriented setup allows SQLAlchemy to handle some pretty advanced SQL behaviors natively. Take cascade attributes, for example. If you define a cascade on your relationships, SQLAlchemy intuitively knows exactly what to do if a parent object is removed or changed. Imagine you need to delete a user profile. In the old days, you'd be writing 5 different queries to manually find and delete all their comments, posts, and settings. With this, the ORM automatically cascades down and deletes all those child objects for you. You don't have to write a separate cleanup script. The ORM just handles it reliably based on the relationship rules you set up right at the beginning.
Section 5, Authorization with OSO, Securing Your App. Okay, so with our tables linked up, data flowing, and cascades in place, we absolutely have to talk about security. We're going to shift gears and look at access control, highlighting a highly specialized system from the source material called OSO. But before we lock down our tables, we really need to separate 2 distinct security concepts. Authentication is simply verifying who a user is, like checking a hashed password against the database just to confirm that he is, in fact, Bob. Authorization, on the flip side, determines what Bob is actually allowed to do once he's logged in. Can Bob write a new post? Can he delete someone else's post? Is he an admin? Building all that complex authorization logic from scratch yourself is, quite frankly, a total nightmare. It's time-consuming and highly prone to devastating security risks. So instead of hard-coding endless, messy authorization checks directly into your database models, you can integrate a tool like OSO. OSO uses this super clean declarative language called Polar to manage fine-grained roles. Out of the box, it supports role-based, relationship-based, and attribute-based access controls. This means you can easily define exactly who can do what, whether it's based on their job title, their relationship to the data, or unique user attributes. But here's the real game changer. It lets you treat your permissions exactly like the rest of your application code. You can test your security rules, log them, audit them through version control, basically keeping your database completely secure without totally cluttering up your business logic. Finally, Section 6, Best Practices in Action, putting it together. Let's see how all this builds into robust, professional, production-ready code. A massive, absolute key takeaway from the SourceForge for your daily workflow is how you manage your database sessions. You should always use context managers. Those familiar with session blocks in Python. Using context managers prevents the utter nightmare of accidental data loss or database locks. It guarantees that when your code finishes its operation, the changes are safely and automatically committed to the database. And if some unexpected error pops up midway through, the context manager automatically rolls back the changes. This ensures you don't end up with corrupted, half-written data just floating around in your tables.
And this is where we truly see the beauty of the ORM in action. We're talking OOP superpowers here. Because your tables are just Python classes, you can literally bake intelligent behavior directly into them. Think about it. You don't want password hashing logic scattered randomly all over your codebase, right? Instead, you can hide your password hashing right inside the initializer of the user class. You can encapsulate a password checking function directly as a class method. You completely bypass the limitations of raw SQL, giving your database rows intelligent, encapsulated behavior that keeps your main application code incredibly clean, modular, and most importantly, secure.
Wow. Okay, we have covered a massive amount of ground in this explainer today. We've moved all the way from basic functional connections to object-oriented superpowers, automated database cascades, and even strict code-based authorization logic. So, based on everything we've mapped out here, what's it going to be? Which approach are you choosing for your next big project? Are you going to stick with the raw, hands-on power of manual SQL? Maybe use an intermediate query builder? Or are you ready to fully embrace the immense flexibility of an ORM like SQLAlchemy to keep things hyper-efficient and secure? The choice is entirely yours. Keep building, keep optimizing, and most importantly, stay curious.